Hello students, it's Nazia Begum here, your physics lecturer, welcoming you all in today's lecture. So, in previous lecture, I have told you about mode of transfer of heat, in which we have discussed about conduction and convection. Now today we will discuss about radiation. So radiation is the process in which heat is transferred from one place to another without an intervening medium. So in case of conduction, what happened? We were having a rod and the energy was transferring by the particles present in the material of that rod. Okay. From one particle to another particle, the energy was transferred from one place to another place, and there the medium was present. Okay. In second case, in convection, what happened? The particles were actually moving. There was motion of particles. The particles which are having heat, they was moving in upward direction. So in both that cases of conduction and convection, we were having material medium. But in case of radiation, there is no need of any medium. Okay. Without presence of medium also, heat can transfer from one place to another place, and the best example of that is the solar energy. Between sun and earth, there is no medium in the space, but then also the heat energy from sun is coming to earth. That means heat does not need any medium for their propagation, and that type of transfer of heat is called radiation. Okay, so from sun the heat is coming to earth in form of radiations. Okay, and in this process energy is transferred by electromagnetic radiation, which does not require a material medium for its propagation. Okay, so in class 12th we will study so many things. We will study about electromagnetic waves and all, but here you have to know only this thing, that heat is coming here to the earth in form of radiation. Okay, and the heat radiation are of wavelength range 8 into 10 to the power minus 7 meter to 4 into 10 to the power minus 4 meter, and travel through vacuum with a velocity of 3 into 10 to the power 8 meter per second. Heat or thermal radiation, like other waves, exhibit the wave properties which will be discussed in higher classes. Now the next topic is thermal conductivity. So what is conductivity? The ability of a solid substance to allow the transfer of heat through it is called thermal conductivity of the solid. So the solid which allow a very easy passage of heat, we call it having a good conductivity, and those which don't allow the heat to pass easily are having the bad conductivity. Okay, now here in front of you can see figure 12.11. Here we are having one rod and we mark different points on this rod. Okay, the markings are labeled as M, M1, M2, M3 to N, and the cross sectional area of the rod is A and length is L. Okay, let M be the hot and temperature is T1. M is the hot point and temperature is T1, and N is the cold point, cold end, and its temperature is T2. Now let the surface of the rod except the ends be covered by insulating material. Why we are covering it by insulating material? So that the rod will not lose heat energy in any other form. Okay, from the surface it will not, because what happen, when the body gets sufficient heat energy, so it start emitting the energy which is called radiation. We don't want the radiation process to happen there. For example, we can understand it by that whenever heat is given to any body, when any body becomes hot sufficient, so when you stand near that body, then also you can feel the warmth. Okay, and why you are feeling that warmth? Because of radiation which is coming out from that hot body. So when we start giving heat to this rod also will emits some amount of heat in form of radiation. We don't want it to be happen. So that's why we cover the rod by insulating material so that the heat energy will not escape from the surface of the rod. Okay, and both the ends M and N will be open. The molecules at the end M having largest average kinetic energy pass on a part of their energy to their neighboring particles on their right. Okay, so at M the molecules are having high temperature, because of that they are having high kinetic energy, and that molecule pass their energy to the next molecule and then to the next and then to the next till N, till the other end N. Okay, so as a result what happened, the temperature of rod keeps increasing towards end N. This is called the variable state of the rod. Okay, till the temperature is changing in the rod, that is called the variable state. But after some time what happened, the one state will come when the temperature at different point will become constant. Okay, that is called steady state. And at this state we will see that the temperature in all the rod is not same, but a little bit difference is there. The fall of temperature per unit distance along the rod is called temperature gradient. Okay, so what happened here actually is that here we are having this rod. So in steady state what happened, the temperature at this point M will be high. Then as we go towards right hand side, the temperature slowly decreases and point N is having the lowest temperature in this rod. Okay, so like this, as we are going away, so with distance the temperature is decreasing. Okay, and this is called temperature gradient, and it is given by dt upon dx, change in temperature with change in distance, dt upon dx. Now let's derive the formula for coefficient of thermal conductivity. Consider a rectangular bar of a solid of length dx and cross-sectional area A in steady state, with its left face at temperature T plus dt and the right face at temperature T. So the temperature at right face is less in comparison with the left face. Okay, let dq be the amount of heat that flows from the hot to the cold face in time dt. So experimentally it has revealed that dq, whatever amount of heat is there, is directly proportional to cross sectional area, is directly proportional to change in temperature, is directly proportional to the time, is directly proportional to the inversely proportional to the distance. Okay, when we combine all the 4 points, okay, when we combine all these 4 points, we are having this equation. But here we are having the proportionality sign. If we want to remove the proportionality sign and to make it equal, we have to introduce one constant k there. Okay, and after introducing k, this formula can be written like this as well. Okay, from here this dt has been transferred this side. Okay, so we are having dq upon dt, change in heat per unit time, is equal to k into A into dt upon dx, which is equals to k into cross sectional area into temperature gradient. Okay, where dq upon dt is the rate of flow of heat or heat current, and k is a constant of proportionality, which is called coefficient of thermal conductivity of the material of this solid. Okay, that means the conductivity depends upon the nature of the material. Okay, now let's try to find out the unit and dimensional formula for k. So from this equation 12.22 we can write a formula for k like this: k equals to dq upon dt upon A dt upon dx. Okay, when we put all the units of heat, temperature, distance and area, we find out that K equals to joule per second per meter per Kelvin, or we can write W per meter per Kelvin. Okay. CGS unit is calorie per second per centimeter per degree centigrade, and this is the dimensional formula for thermal conductivity. Next is application of conductivity in daily life. So first, in winter the metallic handles of wooden door appear colder. Why it happens? Because see, whenever we touch something and that object feels colder, that means the energy has been transferred from your body to that object. Okay. If you touch anything whose temperature is more than the temperature of your body, so that time what happen? You will get burn. Okay, you will get sores. Okay, why this happen? Because the energy, heat energy transfer from high temperature to low temperature. So whenever anything is hot, having more temperature than your body, so the heat will transfer from that object to your body, and that's why you get burn. Okay. But when anything is having a temperature less than your body, so when you touch that thing, the heat of your body get transferred to that object, and that's why you feel colder, because the energy, the part of your body which is touching that object is losing the energy. That's why it feels colder. Second, cooking utensils are provided with wooden or plastic cover handles. Why? Because wooden or plastic cover handles are insulators. They don't allow the heat to flow through them, to pass through them. So what happen when you are cooking something and you are touching the metallic part? Because metallic parts are conductors, so they all become hot, they all having high temperature, so if you touch them you will get harm. But if we use wooden or plastic cover handles, so we don't get harm. A new quilt is warmer than an old one. Why this happen? Because in new quilt more air is there in comparison with the old one, and air is insulator, or we can say air is a bad conductor, so it does not allow the heat to transfer. So whatever heat is there in your body, that heat is not transferred to the surrounding, and that's why the temperature of your body is maintained and you don't feel colder but you feel warmer inside the new quilt. Fourth, birds swell their feathers in winter, and when they do so, they feel air inside their feathers, and as we know that air is bad conductor, so they feel warmer. Ice is packed in gummy bags or sawdust, because sawdust are also bad conductor. They don't let the heat from outside to come inside in the ice packets. Okay, ice cubes. This prevents flow of heat from the surrounding to the ice, and hence ice does not melt. Meat is written here, but it is melt. Now let's discuss thermal radiation a little more. So as mentioned earlier, thermal radiation or radiant energy is the energy emitted by a body by virtue of its temperature. Okay, if a body becomes hot, it gains sufficient amount of heat, then the body start emitting the heat energy, and that is called radiation. So that means radiation is something in which a body start emitting energy by virtue of its temperature, and is carried from one place to another by means of electromagnetic waves, because they don't need any medium. The frequency and hence the energy of radiation depends on two things. First, temperature of the body, and second, nature or the surface of the body. Since thermal radiation belong to infrared region of the electromagnetic spectrum, they are also called infrared radiations. So some basic characteristics of these radiations are: they travel in straight lines with the speed of light, that is 3 into 10 to the power 8 meter per second. Second, they do not require a medium for their propagation. Third, They obey the laws of reflection, refraction, diffraction, interference, polarization, etc. Fourth, when absorbed by a body or medium, it gets slightly heated. Okay. Now there are some phenomena written here, that is reflectance, absorptance and transmittance of a surface. Okay, so what happened whenever the heat energy falls on any object, some amount of heat energy uh, get reflect back, some amount of energy is absorbed by the body, and some amount of energy is transmitted. So here in this diagram you can see incident energy is Q. Okay, some part of this energy Q, part Q1 is reflected back, part Q2 is absorbed by the body, and part Q3 is transmitted by the body. Okay, so here Q1 plus Q2 plus Q3 equals to Q, because Q is the total energy which is splitted in three parts: reflected part, absorbed part and transmitted part. So this we can write it like this: reflectance of the surface R equals to Q1 upon Q, absorptance is Q2 upon Q, and transmittance is Q3 upon Q, where Q1, Q2 and Q3 are the part of Q, which is total energy. So whatever amount of energy we are sending, okay, the total, see what is reflectance? The amount of energy reflected back to the ratio of total energy is called reflectance. Similarly, what is absorptance? The amount of heat energy absorbed by the body and ratio of the energy absorbed by the body to the total energy. And what is transmittance? It is the ratio between the heat energy which is transmitted by the body to the total energy. If we add R, A and T, we get Q1 plus Q2 plus Q3 upon Q, which is equals to 1. Why? Because Q1 plus Q2 plus Q3 equals to Q. So Q upon Q equals to 1 only. Okay. If the surface does not transmit radiation, that time T will be equals to 0. Okay. If the surface doesn't allow the heat to pass through them, no radiation is there. So that time what happened? Transmission will not be there. So that time what happened? T becomes 0. So R plus A equals to 1. So for A being more, R is less and vice versa. So we conclude that good absorbers are bad reflectors and bad absorbers are good reflector. Okay, keep this thing in your mind. I will ask you questions related to this. Okay, these are small lines but they play very important role in your logical thinking. Good absorbers are bad reflectors and bad absorbers are good reflectors. So this is it for today's lecture. Some more terms we will discuss in next lecture. Till then, goodbye, take care, do some productive work, and the most important thing, be healthy, be safe.